And so that's my motivation. Like, JavaScript was my biggest problem. So that's sometimes why it's good when you have some problem. You try to figure out another way to fix that. And so our agenda here, why people use PDF as an attack vector. It's the basic PDF structure, only to point, like, if you never see a PDF structure, I just try to show, like, the basics. I'm not going to get into it. How PDF, just point some tools that we use, like to analyze PDF and daily based tasks. And so here, how we score and some statistic that I have, and some place we could put this research to work. So PDF as attack vector. So Adobe header is everywhere. So that's the point. Like, it's easier to find Adobe header than to find a Windows machine, because Adobe header is macOS, we have some header in Linux, and all that stuff. I don't know about numbers. Do you have numbers about how many millions people use Adobe header?
I think they're just over a billion.
A billion? More than a billion?
Yeah.
Wow. So that's why.
Like all the iOS devices have Apple's reading.
Okay, so that's why. That's a powerful vector. Like, you probably, if you send a PDF to somewhere, it will work. Mm-hmm. So different ways to use. So we could try to target some Adobe flaws, like some 0 days that they're talking about, or some flaws because people doesn't update. We could use that as a downloader. So you have the PDF, but it has some code inside that will download the real malware. So that's only to get into the company, and the easiest way maybe to bypass the first protection, because like download something is not malicious. Probably the antivirus will not alert for that. And embedded files, like Metasploits use a lot, like PDF with some embedded files, like especially for Flash players vulnerability. Or maybe you want to create something because it's a powerful, a powerful file format. So you could create crazy stuff inside that. So, well, that's not supposed that's it's not good. But here it's just a virus total. Like if you look right here, the PDF, the amount of samples we sent to virus total. So we saw that we have a lot of samples. Those numbers not about Unix samples, but a lot of samples, PDF samples. So everybody's trying to use PDF and PDF most of the time. So in summary, like just points, like we have in now computers we have a header. Probably everybody has one. We could target other flaws, as I told, like embedded Flash with target a Flash player flaw and some Adobe flaws. It's not all about flaws. We could use as downloader. We could have a JavaScript inside, like all that stuff. So that's the first step. So the basic structure, like that's how we build and we saw it. I'm not getting too much in details here because I will focus on the research itself. Like I'm just pointing to the basics. So how Adobe header think it is? Like in summary, you have the header, you have a lot of objects, we have the cross-reference table, the trailers, and an end file. Like in summary, that's how the PDF seems like for a header. And here a sample that I got from Didier Stevens' website. And so we have the header, very simple. Like here you have some objects. So you have the cross-reference that points to the offset where the information is and to keep the header faster. And that's it. That's a very simple, it's a plain text. Could be a plain text file, mostly. Like, so that's a very simple PDF. But how it really is for malicious? Like, probably PDF header in the first beginning, if you analyze, it's a malicious type. Like, they could, like, usually it's something like, if you see here, it's basically something like PDF dash and the version, mostly. And they could write this wrong. So that's one of the points that I show that I'm going to score. So the PDF is a malicious type because they could not type PDF dash 1.1, 1.2, 1.6. here is a malware library, Akka problems. Like here inside the objects, you have a lot of potential ways to do something malicious. That's how the malware. And here are more typos, because mostly they don't need those information. Like it will work if you create the objects in the right way. It will mostly be handled by the Adobe. So here's the same. Like here's nothing. Here's problem plus a JavaScript API. We have a JavaScript API inside the PDF. So that's why another reason that they use too much the PDFs. And here it's nothing and still nothing. Like for malicious purpose. And so how we analyze PDFs today? So here are a bunch of tools. Do you guys work with PDF daily analysis? Do you analyze malicious PDF or not? No? That's okay. So we have PDF ID and PDF parser. We have the Oregon PDF framework. It's Ruby. If you are a Ruby developer, you could use to render and parse PDFs. Have PPDF, JS Unpack, online and the command line version. We have some online tools like VCheck, PDF X-Ray. We have a Razorback that they have they do some analysis from source file. And we have a lot of others too. Like so here where I start my research with the PDF ID. Like when you type PDF ID, it's a tool from Didier Steven against a PDF file. It will print something like this, basically. Like if you have the same numbers of objects and end objects, if you have string and string, like if you're building a PDF, if you start an object, you need to have an end object, right? You need to close. So we have cross-reference. So we have the number of pages if they are using encryption, object string, JavaScript, open action, acroform, JBig to the code, rich media, like if you have Flash player embedded, to have rich media. If you have embedded files, like you could have a PDF with Office document embedded, and so to target Office flaw, not the. So embedded a file, you are trying to bypass protection, because if the protection doesn't open the PDF and handle the embedded file too and analyze both separate, like looking only the PDF is not malicious. So that's a bunch of information. So, man, that's unreadable anyway. Like, so this PDF parser and this stuff, like you probably could not read, but anyway you're not going to read. It's the JavaScript, a piece of JavaScript. Like, that's something insane. Like, you cannot read that. So when I first started my research and my problems, I tried to get this out of the PDF and try to parse and analyze to see what's going on. And this is not the most complex. Like, you could break in different objects and handle in this. The Oregon, the image is so bad, sorry. The Oregon framework is the same as the PDF ID, like the full version that you have PDF scan. Like, it will show like what you have. You have object string and objects, string, some parameters here. So you just show the structure of the file. It's not show the payload. So problems that you have analyzed PDF with those tools mostly are manual analysis. So like when you're talking about a lot of samples and probably get thousands of samples per week, that's not going to work unless you have like 1,000 of security research. So that JavaScript, it's a pain. So that embedded file must be analyzed too. Doesn't mean like if you have a PDF file with an embedded file, doesn't mean that's malicious. Like they have the function to embed files for good purpose, not for malicious. They are using for malicious. We have the rich media. So if you have a Flash inside, you need to analyze, like the PDF and the Flash, for example. We have obfuscation, and mostly are signature-based. So signature is like you need to know to protect. So that's a kind of problem, especially when you're talking about something that could be encoded and a lot of obfuscation as JavaScript. So that's some problems. Another problem, like you could have an object with no encoding. So you could add a filter and have encode, so it will look like this. And so what's the problem here? Like the protection should know how to decode that to see if there is something malicious. But you can't have the encode of the encoded. So the protection must open and so see, no, it's still encoded and open again. For example, like this, it's still decoded. Like, in terms for a protection side of view, it's pretty complex that, like, how I will handle that? If I put like a lot of encodes inside, I don't know how many encodes it could have, like if there is some limit or not. Encode forever. So like imagine if I put like 100 encodes here. Like I'll serve the protection if the protection try to open out the encode. So that's another vector of obfuscation that the malicious guys could use, and that's another problem to the research. We need to analyze that. So you need to open out the encoding and analyze. And so imagine like you have like 10 encodings, and so inside that encode you have a very obfuscated JavaScript, and so you need to deobfuscate the JavaScript and work on that. So that's something crazy. Like you analyze like one PDF per week, maybe. So that's kind of JS Unpack signature. Like if you try to look for something like for media.newPlayer, and so you triggered out, possibly you have this CV inside this PDF. So that's a kind of simple and pretty easy to encode and bypass. But that's so like signature based. And so based on all this stuff that I talked and complain and say that's not that good, sure that we need that, all that manual analysis and other things. I was frustrated that I could not parse the JavaScript and all that stuff, and I tried to see a different way to detect the malicious PDF. So I start to analyze PDF. So I analyzed thousands of malicious PDF. Like, I think I analyzed with the structure. I didn't take care about the payloads. Because if I need to look into all payloads, I'm still researching about that. So something around 20,000 malicious PDF I analyzed. So it's a good number. A lot of regular files. Like in the beginning, I just grab a couple, something. But currently, we have this scoring running in our mail server. So we receive a bunch of PDFs. So we have a good research like to see when you have some false positives. And I will talk after, by the end of the talk, like some problems that you have. Like one of the problems you have, like, and you notice, like when we're talking about buffer overflows, like the exploitation about some headers problem, like they showed like the U3D two different exploits and the talk, and one they just changed a bit the function, like so they doesn't change the structure. So if you don't change the structure, I will not detect. So that's the bad side for us. But when we talk about exploit kits, that's mostly what's arrived for us. They use it to change a lot the structure. So that's the good news. And so we have another point. We have samples from 2007. Maybe I think we have some from 2006. And so that's the big true. Like the payloads changed a lot. But if you look, the structure are mostly the same. So that's the trick. Like analyzing a lot of samples, you saw that the malicious PDF, it's supposed to have those structure. Like if you run PDF ID, it will have some like 1 page, 0 page. They will have like some JavaScript. They have op action. You have some combination of that, and so it will point that it's malicious or not. And so here are some functions that we detect, like analyzing, like the malicious sample. So how I started? I started with five functions, like what I saw, like JavaScript and open action and one page, and basically I run the PDF ID, for example, and if you have one page and JavaScript, I will score 1. If I have JavaScript, I score +1. So it's part of the PDF ID, I will score something. And so like my very first version, it was 5 things, like if it was the score bigger or equal 3, it will alert. So I just run against the malware, worked. But when I run against the regular files, it worked too, like everything is malicious. So that's not okay. So I figured out, okay, I need to improve that. But the good side was I could detect. I know that we have a behavior here. Like, so what I figured out, like, okay, I will run against the malicious and against the regular files. And I will try to find more and more functions. Let's call functions. Everything is a function. So basically, now we analyze more than 20 functions, 20 outputs, different outputs. And we analyze some combination of that output. And so, for example, like some behaviors add like something 1.5, something, for example, and some will decrease the score. So you could have a balance for regular files and non-regular files. And so that's the trick, like the mix of combination of scoring, like it's a bit similar like anti-spam. Like anti-spam, we got like if you have reverse, if you have something related with IP reputation, if you have this subject, if you have that, oh, it score more than my threshold, so it's malicious. And so that's how I pick that. And so we look for JavaScript stuff. JavaScript, you could see like around 75% of the malicious file have JavaScript. So that's a good vector. Like if you have JavaScript and if you have flat decode, that's most common encode that they use. It's called flat decode. And if you have one page only, it's pretty common that the malicious PDF has one page only. So like you could say that, okay, so if I have those 4, it's malicious. No, it doesn't work. That's the problem. Because we have a big problem, and that's where I work more, I spend more of my time turning those numbers or the scoring, is the forms. When you have a PDF with working as a form, they have JavaScript inside, they probably could have some embedded file that's crazy. And so that's where you need to find some gaps and some more points to score and increase the score. If you ask me like how you choose the scores that you're talking here, I will show more. But it's try and error. That's how it's worked. Like we are going to improve that because like I work as research and this started as my free time stuff. Like I'm doing nothing now, I will try to do something different. And until you prove that this really works, the company will not really care about that. Because they will not put money and say, oh no, here's a couple of machines, build a lab and something more intelligent. And no, that doesn't work, right? So now it's working. So, but this is have something like I say, like I think it's for 1.5 to something that would decrease 0.5. But it's something like we have some 0.735 at score. That's not a learning machine, it's my brain machine. Like, let's try this. And so try again, and try again, and try again. That's how, and it worked. And so, as I told, we compared, like, so let's compare the same functions. In red, it's the malicious, and green is the regular, right? And so we start to compare. Look, if you look on the regular files, only a couple have JavaScript. So, okay, so when you saw these JavaScript functions, you could score more. but itself doesn't mean that's malicious, but you could add a bigger score than something that's it's pretty common, something like, so that's interesting, like one-page PDF. So in samples that I analyzed, that's pretty common to have only one-page PDF. So like it's pretty equal, so I could not add a lot of score because, and so here you have the biggest difference, like JavaScript is pretty unique. If you get like acroform, it's most common in malicious files. If you get like action and AA, that's a kind of action, it's most common in malicious file. Open action is most common in malicious files. So I add a little bit more of score. So that's how it's, but here that's something crazy because when I start, I suppose the cross table, that end object and start object, that need to be the same numbers, will be most incorrect in malwares, but the regular files, they are more common. I don't know why they. And so like the JBig decode, like it's more common in regular files. So working with this information, we start to point the score like, and so like if you have these, will increase the score. Like if you have that, will decrease the score. So we start to balance. And another point is the file size. That's the interesting part. Let me see the time. That's the interesting part when we're talking about behavior. If you look, doesn't matter where in the file or somewhere, you always find some big difference in somewhere. Like here, in the file size are mostly the same, but in this 11K to 3K file size, it's where like almost 45% of the malicious samples sit. So I could, based on the size, add some score to. Because like they're just supposed to be smaller, especially because PDF could be, and it is, almost a plain text file with a lot of functions, and when it's rendered, they are beautiful. And if you're doing something malicious, it just puts a bunch of information there. Doesn't need to be a big file like. And so here you have some parts it's almost equal. Like it's not a big difference that I could say no, I could add some score here or not. And that's fun that you have very very big files. Probably there is some files that have like 10 embedded files and that crazy things, and they are not malicious. I don't know why they need too much files. And I think there is a book that they call PDF hacking or something like this, but not PDF hacking for malicious, but PDF hacking to create good PDFs, smaller with well. And so the file size, besides all that function, is another vector. And so that's bad. After doing all that, based on that statistic analysis and create this scoring, we run all the samples against VirusTotal and against PDF score. That has the call. What surprised me a lot, GData is the best antivirus ever for PDF. I don't know, because I don't know nobody that uses GData, but they are really good. I don't know if you could see here, GData, they have something around 95% detection. That's insane. So PDF score was the second. Like when I started the research, PDF score was better than GData. Now they are better than us. So I get a little frustrated. I need to improve my research. But we are detect something around 92 to 93%. What's awesome, because we are not looking for payloads. And like if they release some new PDF, we will detect. Unless they start to change how they write the PDF. But they need to use the functions, and some of the functions will be somewhere and they need to print. And so like the third one was Avast, Sophos, Kaspersky. And here, I don't know what is that, squared. I never heard about, but it detects like 0.1% of the samples. That's
But it never found a false positive.
no, probably is a false positive. Yeah, probably is not the only like, and some antivirus like I suppose that Node 32 was good. They are not good. As I suppose Panda, I get like little surprise. They are very bad with PDF at least. Like those tests are related with the PDF samples that I tested only. Like it's not related about. And so, like we have those. So we are the second now. Like we got more than 90%, what is a very nice detection rate, and especially because we are running in the real server, a real world, like we have in production. So we really care about false positives because our customer doesn't like when you block a form, like because usually something important. Like, and that's fun, like because our engine, it's run after the antivirus. No, after the antivirus. And we are detecting and blocking around 1,000 samples a day. So you could see like, I'm not going to say the name that antivirus we use, but they're not doing very well. And basically what we scored, like currently 20 more functions, like, and I'm working on more research to improve in the next months. Like I'm working, like I noticed that we have some very uncommon, when you run PDF ID to output everything, you have some crazy names and some long names that are in the malicious files that I'm getting to add to this and probably will help more. I'm looking again for new features that I could try to print and create that kind of comparison, like, oh, here's the regular, here's the malicious, oh, here is the big gap, so here's I put more and less point. We have some combinations flag, like we have a flag that we call the magic combination. That when you have something that has an open action or something that will make something open when you open a file, combined with something that could be malicious as an embedded file, a JavaScript file. And I don't know, I don't think I showed, but if you came here, where is it? That's the big difference too, you see? Like the magic combination, that's something action but a malicious. It's mostly happen only on the malicious samples. And that's a trick, like where you get something that's really relate with the malicious only. So you try to see different behaviors, and we work with a threshold. Like that's a good size. Like if they change how they write malicious PDF, we could decrease or increase the threshold, and so we have like some good results. Like we will keep improving that, and we could try to see what is going on. Maybe need to do everything again and create some status. But basically, it's how it works. And to see like how this is dynamic and different, like this, we got almost 100 different scores. So we score a lot of things in different ways. Like, so the most common score was this number. I'm bad with numbers, so I'm not telling the numbers. It's 6.8 something. I get confused. And so like the threshold that we are using now is 2. Like so any score bigger than 2, it's malicious. And so like we have like some crazy numbers. Like you could see like the numbers that I'm using, because like we have 7175. It's all different numbers. And one of the points, it's a bigger result. It doesn't mean that it's more malicious. Like it's just a combination of stuff. Like doesn't mean like if this is 4.5 and the other is 10, doesn't mean that the other is more dangerous or this is less dangerous. So that's the way you do something. Like we have one page, so we detect to have the JavaScript stuff. We have open action. we have acroform, we have action. So we have open action, action, and JavaScript. So we have the magic combination, like, and so I don't remember the values here by head, but we get this plus this plus this plus this plus this plus this. You get the score of 4.5, and so we tell no, this is malicious. Why? Because it's bigger than 2, and these combinations point to something malicious. And so it's something like I'm doing something very simple. I'm doing probably the opposite at most people try to do. Like they look and try the complex stuff. I'm just looking to the basics, like the structure. And false positive, as I told you, we are running our mail service, so we test a lot. So, and we have a lot of ideas to improve that. And one of my ideas is to release a code about this scoring stuff. I could not release so far, but I hope I could release in future. And especially because I need to improve. And the funnest part, like my proof of concept, is a Perl script that I did. What's mean that it's not good, but it's work. It's something around 200 lines. It's nothing compared with an antivirus solution or something protection. It's nothing, and you got like something around 93% detection. That's crazy. And if you look at the same approach that you use, look on the structure and behaviors. I don't know if you saw another Rodrigo spoke at Black Hat. He works for Qualys. And he did the same approach for detection binaries, malicious binaries. But like if you have a packer, if you have anti-debugging, if you have something, so this is malicious because it has that. A regular software doesn't have, besides Skype. So another point, like, is this file malicious? Like you have bad cross-reference table, it has 0 page. That's great. Sometimes it points like 0 page. Why a file has 0 page? They have open action, they have action, and so this is malicious? No, this is not malicious. Like, that's clean. Or it's a big false negative for all the industry, like, and PDF score. But what's the trick here? Like, if you look, you don't have like the malicious stuff. Like, you don't have JavaScript, you don't have embedded file, you don't have something that could hurt. Doesn't matter that you have an action, for example, that you do something when you open a file. So it's not malicious. I'm on time. So, any question about the research itself?
Have you tried looking at it over time to see if the scores change as people find new exploits or old exploits get fixed?
I compared, like, I use, oops. In PDF I have access, so I get a little bit paranoid, like, and I run against PDF score, like, and as I told you, like, they change mostly the payload, but they always keep the same structure. They don't care yet about that because the protection companies, the antivirus companies, they don't look for that. So why they are going to change? Like, it's the same as Brazilian malwares. If you look the code, it's a piece of shit. I already downloaded a file, a malicious Brazilian banker with 37 megabytes, but it works. So why they do something better? And so, oops. And so I think that they didn't care about the structure at all. So as I told, they changed the internal payload, the JavaScript, or where they're targeting, but they need the JavaScript, they need some open action, because they need to, when you open the file, they need to run something. And so it's mostly the same. I don't know if there is some way to avoid this and have the same success rate. Because maybe they will try to do some interaction with the user. Click here to run this. And so I don't know, maybe it's not going to work. Because like it's pretty common, like you want to get inside the company as like you put an embedded file in a PDF and send to the human research, like, oh, here my resume, take a look. And so she will click, something you run in the background, you never know, and you probably will be inside the company. So that's how it works. And so where to use it? Some ideas, like to use in some web application firewall, like so you could avoid the malicious guy to host malicious content in your server. So that could be a good point, especially if you get the big content provider as Amazon and Google. They have a bunch of samples malicious being hosted. Some content filtering, like you could like avoid if the user is trying to click in some phishing link. We could try to protect maybe with the scoring, and so. But in real time, it's I don't know exactly. Like in the mail server, like if you have like 1 second delay, like analyzing a file, it's not a big deal. But on the real time, like content filtering, but it's only about the PDF, so maybe it's not a big problem. Running with the AV agents. For AV, maybe it's difficult because like it's too generic. Like they will alert for something like unknown malware. So maybe they don't like that idea. You could use some scripts to try to find something. And then you could do something in the header integration, like analyzing much more samples. Like probably have millions of samples that you could have access. Create a very good score, and when a user opens something that seems to be malicious, like based on the score, just alert. You're not going to block. Just alert. As Microsoft with, if you have macros inside, oh, this file contains macro. Do you really want to run? And maybe you could do the same like this, as you did with the U3D. Like, this file contains this is malicious. Do you want to open, or do you want to open without JavaScript, or maybe you want to open, or no, just close. So that could be, I think here is the place, because you teach the user to click on the correct stuff. But doesn't depend on me, or or maybe some in the not IDS integration by itself, because it's hard to put this in the real-time traffic. But Razorback, it's almost real-time analysis that it's send and analyze and so generate alert. That could be a good place. That's some ideas. And at mail server, as I told already, like some research. We have a blog.spiderlabs. We have the global security reports that has a bunch of information that all the information we handle. The Spider Labs Twitter and my Twitter is a kind of similar. It's about labs. And questions. Speak slowly, please.
Did you find that the same structures were common in malicious files that targeted other readers? For example, things that targeted Apple Preview instead of Adobe Reader?
Well, somebody I read asked him this question, and my answer is like, I really don't care about the header, because I just received the PDF, and the PDF is my playground. Like, I don't know if the PDF is trying to do something for Acrobat 6, 7, 8, 9, 10, or if you're going to work on Linux or Mac OS only, or maybe that's something that I never pay attention, because I'm only looking at the structure, and if I need to look and now that information, what's the target, the real target, I'll probably spend too much time.
Also, I was wondering, like, if you could have determined whether what it was targeting, just, in your samples, did you simply say, is this PDF malicious or not, or did you actually look for, PDFs which target Adobe Reader versus PDFs which target iOS versus PDFs which target Apple?
Well, when I started the research, I talked to the certified guys, the VRT. They have the Clan AV, and they shared a lot of samples with me and say, those are malicious. Here you go. And they are public, so I sent to VirusTotal just to make sure and see the detection rates because I want to compare. I could try to figure out where it's supposed to hit because some VirusTotal will show a good name and say, oh, this is CV 2011 something. And so you know that, oh, this target the Adobe version, blah. But I never do that. If you want, I could share the whole VirusTotal results. Right? There is no secret. It's a text file with all the results. It's a Ruby script that go and it took forever because it.
I was just curious whether there was a pattern that is commonly used to attack
Yeah.
preview, which is not commonly used to attack reader, or vice versa.
Okay, but no. My only goal was to detect the malicious one, and doesn't matter which one is the target. Any questions? More questions? All right. So thank you.